Welcome to Test 2 Prep. Today we'll go over some of the content that will be on the test. So the time and date of the test is Tuesday, November 6, 2018. It's 2 weeks from today. You will have, online students will have a 24-hour window on Tuesday, essentially starting 1 minute past midnight all the way to 1 minute to midnight on Tuesday. For students in the I-course section, we'll meet at the scheduled class time. The time for the assessment, time for the test will be 1 hour and 15 minutes, which is the scheduled duration of the class. Content covered is only chapters 8 and 9. This test will not be as long as the first test in the class. It will cover more concentrated information. You'll have multiple choice section and a long format question. So your multiple choice questions will be, there'll be about 15 multiple choice questions, 5 to 6 points each, mostly covering balanced and unbalanced faults, symmetrical components concepts. There's one question on, or two questions on fuse coordination, essentially know how to read and interpret the time current characteristic curve with a log-log scale to interpret what time it would take for a fault current of a certain magnitude to clear given certain fuse characteristics. There will be no partial credit for the multiple choice questions. For the long format question, it will cover chapter 9. It's essentially a question on fault current calculations utilizing symmetrical components. You'll be given a circuit. You will have to analyze the circuit for different fault types, single line to ground, line to line, double line to ground, and three-phase, after having calculated the Thevenin impedance for faults at certain locations on the system. You will need to understand from chapter 8 and 9 how to model the circuit, calculating your impedances on a consistent base, modeling the circuit with various transformer configurations, identifying what Thevenin impedance is at various locations in the system, and how the sequence networks, positive, negative, and zero, are put together to analyze the various fault types. For example, a single line to ground fault. On a grounded system, you would put the zero sequence, positive, and negative sequence networks in series. You have a source or short circuit current, and the positive, negative, zero sequence current magnitudes depend on the impedances of those particular Thevenin networks. You must understand how to treat a neutral resistor or reactor if given a neutral reactor on a particular circuit. You should understand at this stage how to convert or how to represent that neutral conductor or neutral impedance in the sequence networks. A great example of that would be as follows. If I have a neutral impedance of 0.1 per unit for the quantities on the transformer base in zero sequence, this would be represented as 3 times the neutral impedance value, so 0.3 in the zero sequence network. Focus areas identified as follows, and homework problems are identified to help you narrow down your study effort. Okay. And from chapter 9, Chapter 9, we'll be covering, again, calculating Thevenin sequence impedances and configuring them for fault analysis. That should prepare you for the exam number 2. Good luck. Thank you.